So we're now going to talk about synchronized collections. And this is the beginning of a series of lessons on collections that can be used in multi-threaded contexts without users being responsible for doing the locking themselves. And we'll talk about the synchronized collections that are provided out of the box with Java and some of the limitations with those approaches. By default, Java collections are not synchronized. So if you try to use, say, ArrayList, and you've got a producer thread and a consumer thread, and they're both adding and removing from the list at the same time, chaos and insanity will ensue. And if you take a look at the ArrayList documentation, it says the implementation isn't synchronized. Therefore, if multiple threads access an ArrayList instance concurrently, and at least one of the threads modifies the list structurally, in other words, adds or removes an element, it must be synchronized externally. And what it doesn't say there is, or race conditions will occur, because you'll have things colliding and corrupting the state. So that just means that they're not thread safe. So code is thread safe if it only manipulates shared data structures, in other words, mutable shared state, in a manner that avoids race conditions by multiple concurrent threads. Okay, so how do we solve this problem? Well, one way, of course, is to put locks in the code yourself, but that gets ugly, and why reinvent the wheel? So an alternative to doing the locking yourself externally is to use one of Java's built-in synchronized collection wrappers. And there's a bunch of factory methods that are defined on the collections interface, collections class, that take a collection and make a synchronized version of that collection. So you can see there's 4 different methods: synchronized collection, synchronized list, synchronized map, and synchronized set. And what these wrappers do is they ensure that the method calls are thread safe. So here's an example of this. Here's the synchronized map method. And you can see that synchronized map, when you call synchronized map, it takes the map that you pass in and it wraps it inside a synchronized map wrapper. And here's how you could use this. So what you could do is you could make yourself a good old-fashioned map, like you always do. This is a non-concurrent hash map. And then you could wrap it with a synchronized map. And notice how you can even reuse it. So we make a map, we then take that map and we wrap it with a synchronized map, but we can still call it mmap. And then we can go ahead and do a bunch of things. We can go ahead and have multiple threads that are simultaneously putting and getting into that map, and all those things will be properly synchronized. They will not have race conditions. They will work correctly in multiple threads. Here's what the synchronized map wrapper class looks like. And I'll just show you a little snippet of it, but it's pretty obvious what it does. It's very simple. It just adds a lock. And you can see here how it works is we have the synchronized map class, which implements map. It has a map field, which will be used to store what's passed in as a parameter. And then it goes ahead and defines a field called mutex of type object. Really bizarre, but that's what they do. Keep in mind, this is done very early in Java, so this is before they had things like reentrant locks and so on. And the constructor then takes the parameter and stores the parameter in this field called m, and then it assigns this object to mutex. And then whenever you call a method, like you call the get method, what that does is that goes ahead and synchronizes on the mutex, and then with that lock held, it goes ahead and delegates to or forwards to the map, giving it the parameter it wants to look up. And this is actually an implementation of the decorator pattern from the Gang of 4 book. So that's basically how things work. So it's very straightforward. There is a problem, however. Synchronized collections are not optimized for concurrent access. So they work properly in multi-threaded programs from the point of view that they don't blow things up. You won't have corruption of your state. However, if lots of threads are simultaneously getting and putting on the synchronized map, if you have lots of threads trying to get into that map, they're all going to end up contending for the single lock. And so as a consequence, you'll have a lot of contention. So that's the downside with this particular approach.